Okay, question 30 reads, a biologist grows a culture of bacteria as part of an experiment. At the start of the experiment, there are 75 bacteria. The biologist observes that the population of bacteria doubles every 18 minutes. Which of the following equations best models the number n of bacteria t hours after the start of the experiment? Okay, we can automatically cancel out choices B and D. And the reason why I say this is that both of them, the common ground between these two choices is that they are linear equations. And so how do I know we are not looking for linear equations in our answer? Or in our answer? It's because of this key word right here, doubles, okay? Doubles means that our relationship in this question should be exponential. That is the key word. We need to have an exponential equation. Exponential equations are in the form a into b to the power of x, right? And so a and c look somewhat like they're in that form, right? And b and d are simply linear equations, and so they do not match what we're looking for. And so we can cancel out b and d, and now it's all about choosing between a and c. The best way, I would say, to answer the choose between A and C is by creating two data points that we can rely on and plug in. Okay? And so the question says the biologist observes that the population of bacteria doubles every 18 minutes. So 18 minutes elapses, right? The population doubles. If we start with 75, doubling the population would be 150, right? And so 150 equals n, right? N is the number of bacteria. And so after 18 minutes, we should have 150 bacteria. The problem now is that some students will plug in 18 directly. And this is the trap of this question. What makes it difficult? Because T it's not in minutes, but it's in hours. And so we should convert the 18 minutes into hours. And so the way we can do that is conversion factor. 18 minutes, 1 hour has actually 60 minutes, right? And so the minutes can cancel out. And so that is 18 over 60 gives us the hours of 18 minutes, right? So if I take out my calculator, that is 18 over 60. That should be 0.3 hours, right? So 0.3 hours is equivalent to 18 minutes, okay? And so our two data points, this is the important part, our two data points that we should plug in, and the equation should be accurate. It should be 0.3 and 150. If the equation is true for both these values, then that's the answer choice, okay? So let's try to plug in 0.3 into question C, answer choice C, okay? So T, comma N, right? So if 75, this is all over the place, but I hope you can follow. 75 into 2 raised to 10 into 0.3 over 3, okay? What that equals is 75. I'll just erase this area right here. What that equals is 75 into 2. 10 into 0.3 is 3, so 3 over 3. 3 over 3, 75, it's just 75 into 2 to the power of 1, which is equal to 150. And so that's our answer, C. C is gonna be our answer choice. If we plug in 0.3 for A and use the calculator, you'll notice that it's gonna give something else. And yeah, that's how we do this question. The key idea and what makes this question slightly difficult is by picking up on the idea of double for exponential, right? Exponential. And T hours, okay? And converting minutes into hours. And so our answer is C.